Okay, so we're going to talk about even and odd functions. We did a drill on this and we came across some of the properties, and we're going to revisit those properties, and then we're going to figure out how to determine whether two functions are even or excuse me, whether a function is even or if it's odd algebraically. So if you remember back to the drill, a function is an even function um, if it was symmetric to the y-axis. So basically it was a reflection of itself over the y-axis. And one of the properties that we came up with on the drill was that no matter which side of the y-axis we put an x value in, so if we put a positive x value in and we put the same negative x value in, it gave you the same exact y value. Well, that is actually going to be the test algebraically to see whether something is an even function. We want to say that if I take the function and I plug in x, or if I take the function and I plug in the negative of x, or the opposite value of x, it will be exactly the same y value. So the f part is going to be exactly the same. For an odd function, we said that the symmetry for the odd function was around the origin, meaning that we could rotate the function 180 degrees, or basically just take your paper and flip it over, and it's going to look exactly the same as what it did before. And the test for that one, if you remember, we said that the x's and y's were exactly the opposite sign for the odd function. So if you have a positive x and a negative y, then you would get out, then you would have, excuse me, the exact same point, but the opposite sign. So you would have a negative x and a positive y, if I said that right. I'm not sure if I did. Um, but here's the test algebraically. The algebraic test is that if I take and I plug in negative x, I'm getting out some kind of a y value, but I should get out exactly the opposite y value if I plug in the opposite x. So f of negative x will have to equal the negative of f of x. And that's the test for odd functions. So if the function does not fit either one of those categories, it's just called neither. And of course, there's probably way more neither functions than there are even or odd functions. But that's the general idea. So let's go ahead and look at these graphs. Graphically, I think it's pretty easy to see. Um, the first one, if I were to take that and try and flip it over the y-axis or mirror image it over the y-axis, it would not lay on top of itself. And if I rotated that 180 degrees, which you can actually do with your own paper, you would see that this is not going to look exactly the same as what it did. So this one would be neither. I think number two is pretty obvious. That is a completely mirror image of itself over the y-axis. So this would be an even function. Number three also appears to be a mirror image over the y-axis, so it would also be even. Four is definitely not even. It is not a mirror image of itself over the y-axis. It does look like that if you turned it completely upside down, however, and rotated it 180 degrees, it will be the same exact function. So this one is odd. Number five is also odd, where if you rotate it 180 degrees, it will be exactly the same. And number six is not a mirror image over the y-axis, and nor is it a rotation around the origin going to look the same. So this is neither. Okay, hopefully visually you can see those. Usually the graphical representations are the easiest ones to tell. All right, to verify algebraically if a function is even, odd, or neither, you have to prove one of the following. For even, like I said, you have to show that f of x equals f of negative x, or in general it just means that for every positive x value, the negative x value is going to produce the exact same y value. For the odd proof, you need f of negative x to be equal to the negative of f of x. So again, the idea is if I plug in the positive x value and I get out some negative y value, then if I plug in a negative x value, I get out a positive y value. and they should be exactly the same other tn the sign. So that's kind of the idea right there. All right, let's go ahead and take a look at this algebraically. In order to do it algebraically, since you're given f of x, the easiest way to start is to try and find out if something is even. So in this case, we're given f of x here, which is x squared plus 3x plus 5. So if I want to test for even, I want to find f of negative x. It just means I'm going to plug in negative x where every x is. So if I want to find f of negative x where every x was, I'm going to plug in negative x. And then we're going to simplify. So let's see, the negative x squared, so if you multiply negative x times itself, you get x squared. 3 times negative x is minus 3x, and then plus 5. This x squared minus 3x plus 5 is not exactly the same as that because of the minus 3x and the plus 3x. So this is not even. Okay, so now we need to check and see if it's odd. Well, the odd test is whether f of negative x, which we just found, is equal to the negative of f of x. In general, the negative of f of x is the easiest one because if I want to take the negative of this function, it literally means I'm going to multiply everything on the function by a negative. Must be the end of class. All right, so that means if I distribute the negative sign throughout, oops, forgot to distribute to the 5. So the negative of f of x is negative x squared minus 3x minus 5. That is not the same. These two things are not the same, so this is not odd, which just means in this case this would be a neither function. All right. Let's take a look at some more examples. So we're going to just determine algebraically whether the function is even, odd, or neither. Again, the easiest thing to do is check for even first. The even test says plug in negative x for all the x's. So if I do that, I'm going to get negative x cubed minus 6 times, try that again, minus 6 times negative x. And then we'll simplify. Negative x cubed is negative x times negative x times negative x. If I multiply 3 negatives together, I still get a negative, so we get negative x cubed. And then negative 6x times negative 6 times negative x is plus 6x. These are not the same. Not even. F of x does not equal f of negative x. Now let's try the negative of f of x. Well, that is literally just making the entire f of x function negative. And then we'll simplify. We'll distribute the negative, so we get negative x cubed plus 6x. Aha. This is the same as that. This is an odd function. It just means that when you graph that, that would be rotationally symmetric to the origin. All right, a few more examples. All right, we have g of x equals x to the 4th minus 2x. Let's test for even first. G of negative x. So if I plug in negative x for every x, and then simplify. Negative x to the 4th power is an even power, so it's going to become x to the 4th. And then minus 2 times negative x to the 2nd power will become positive, so that's x squared. And this is exactly the same as this. The nice thing about this is once you find that it's even, you're done. You don't even need to test for odd. There is only one function that's actually both even and odd. If you can figure that one out, I'll give you a piece of candy. Just kidding. You can have the candy anyway. All right, number 3, even, odd, or neither. So let's test for even. So if I plug in negative x, let's see what we get. Negative x squared is just x squared. 2 times negative x is minus 2x. Plus 1, that was close, but not quite, because the minus sign in front of the 2x and the plus sign in the 2x and the original function. So this is not even. Let's check to see whether it's odd. So we'll have to do the negative of h of x. That means put a negative sign in front of my function and distribute what I can. So that's going to be, what is that, negative x squared minus 2x minus 1. This does not match. These two things are not the same, so this is also not odd. This one is neither. Not even, not odd. All right, f of x is x squared plus 6. Let's check even. So we'll substitute a negative x in and simplify. Negative x squared is x squared plus 6. These two things are the same. This is an even function. And before I go on any further on this, I want to make sure you guys understand that if you know your parent functions, this is not that challenging, because the parent function is x squared, which most of us already know is an even function. Well, x squared plus 6, the shift is up 6 units. So now all I've done is I've taken that same quadratic and I've shifted it up 6 units. Of course, it's still going to be even, because all it did was move up and down. All it did was slide up. And we did talk about that with the drill. We shifted the even function up and down the y-axis. It doesn't change the fact that it's even. You shift it left and right, it will, but up and down does not. So just a little pointer there. So if you know your functions and you know how the shifts work, then you should probably already have known that that was going to be even anyway. But we did need to show it algebraically. All right, number 5. G of x is 7x cubed minus x. So let's check for even. So let's see. Plug in negative x and simplify. So negative x cubed is still negative x cubed, so that becomes negative 7x cubed, putting the negative out in the front, and then minus minus x becomes plus x. Not the same as the original, so not even. Let's check for odd. So we'll do the negative of g of x, which just means make everything on the inside. We make everything in the function negative, so that's going to be negative 7x cubed plus x. These two things are the same now, so this is an odd function. Again, rotationally symmetric to the origin. All right, last page. And there are a couple of challenging ones on here. I am only going to do one of these on this page. You guys are going to be responsible for the other ones for your homework. I'm going to do number 7, and we're going to take a look at that one just to see what that's like. You're going to have to do 6, 8, 9, and 10. Yeah, I want to make sure there wasn't any extra ones. All right, number 7, last one. Let's check for even. F of negative x. So if I plug in negative x, where all the x's are, and simplify. Negative x on the outside just stays negative x. On the inside, negative x squared is x squared. So I get 4 minus x squared. It's close, but it is not the same as the original. Therefore, this is not even. And then we'll check for odd. The negative of f of x is going to be, put a negative out in front. You do not put a negative on the underneath part, because you're only putting a negative out in front of the whole function. and I cannot distribute a negative into a square root, so this is it. That's all you can do. Well, this is the same as this. So this is an odd function. All right, the ones that are left over are your homework. Good luck with that, and let me know if you have any questions.